Hello, welcome back again. And let's now discuss about a relay. What is a relay? A relay is an electromechanical switch. It is an electromechanical switch which receives a signal in terms of voltage, either high or low at the input. It has mechanical and magnetic parts inside. That's why it's electromechanical, because the signal, the electricity that it receives at the input actually operates or induces magnetism in the coils that are inside, and the coils pull the switch or the connector to either normally closed or normally open position. So that's why it's called electromechanical switch, because it has electric parts actually, and also it has mechanical parts in it. Now, how does it function? As we see, there are three terminals at the input. We have ground, 0, 5 volts. So this is the supply voltage. When the supply voltage is given, now this thing is in high mode and then waiting to receive the signal to either turn to now normally closed or turn to normally open, depending on the connection that we have at the output. So when it receives a positive signal, which is 5 volts, if initially the connection was normally closed, it will turn to normally open. If it receives a signal which is 0 volts, if the connection was not initially normally closed, it will remain normally closed. So that's the way. If the signal is positive, it switches from normally closed to normally open, or normally open to normally closed. But if the signal is 0, nothing is done. The status remains unchanged. Relay is used in many switching applications. So it's triggered by a low voltage, DC voltage, but then it can be used for controlling many kind of interesting applications. For example, we cannot connect our normal Arduino with a circuit which has AC signal in it. It will destroy our Arduino. So if we want, let's say, to connect or to control AC signals like the lamps, AC lamps, or even fans, the AC fans or lamps or bulbs, we usually use a relay. Why? Because a relay, the primary side is low voltage, so you can't do anything with AC here. But on the output side, it's actually designed to handle AC signal. So the output of a relay is handled. The normally closed, common, and normally open terminals are handled, or are kind of in a way designed to handle high voltage. So when we have all the switching that requires AC signal, every or any switching that is of high voltage requiring AC signal, we usually use a relay rather than just using, let's say, an Arduino directly. So that's why we are applying it here. Of course, in our simple description, we are not going to use any AC signal, but we thought that it's actually a great starting point to start showing what it actually does. So an Arduino will be connected to the signal part here, and will also receive 5 volts and ground signal from the Arduino. But then the output will be connected to STEMX1 equipment, because that is the one that either controls the switch, okay, and actually improves the switching. So this can be used, the output can be connected both for AC and DC. So there is that level of flexibility. That is all about a relay. Those are the important things about a relay that you need to know now. So if we are connecting anything to the output, we'll connect either common and normally closed or common and normally open. When the signal is positive, meaning when the signal is high at the input, if it was initially normally open, it will turn to be normally closed. If the signal is negative, If the signal is low, let's say 0, if it was initially normally closed, it will remain normally closed. That's how a relay operates simply. Thank you for listening.